Good morning everyone, we are the group 2 and today we will tackle about probability, concepts, and applications. After completing this chapter, the students will be able to understand the basic foundations of probability analysis, describe statistically dependent and independent events, use Bayes' theorem to establish posterior probabilities, describe and provide examples of both discrete and continuous random variables, explain the difference between discrete and continuous probability distribution, and lastly, calculate expected value and variances and use the nominal table. Life is uncertain. We are not sure what the future will bring. Life would be simpler if we knew without doubt what was going to happen in the future. The outcome of any decision would depend only on how logical and rational the decision was. Before we proceed, let us define probability. So what is probability? Probability is a numerical statement about the likelihood of an event will occur. Always avoid building a plant that was too large, investing in a company that would lose money, running out of supplies, or losing crops because of bad weather. There would be no such thing as a risky investment. Life would be simpler, but boring. It wasn't until the 16th century that people started to quantify risk and to apply this concept to everyday situations. Today, the idea of risk or probability is part of our lives. Before we proceed, let us define probability. So what is probability? Probability is a numerical statement about the likelihood of an event will occur. In this chapter, we examine the basic concepts, terms and relationships of probability, and probability distributions that are useful in solving many quantitative analysis problems. There are two basic rules regarding the mathematics of probabilities. So the first one is, the probability of any event or state of nature occurring is greater than or equal to 0 and less than or equal to 1. It means that a probability of 0 indicates that an event is never expected to occur, while the probability of 1 means that an event is always expected to occur. Then the second one is, the sum of the simple probabilities for all possible outcomes of an activity must equal to 1. Regardless of how probabilities are determined, they must adhere to these two rules. There are two different ways to determine probability: the objective approach and subjective approach. Objective approach means having due regard for the known valid evidence, such as relevant facts, logical implications, and viewpoints and human purposes pertaining to the issue. It is also the probability of any demand level is the relative frequency of occurrence of that demand in a large number of trial observations. So what is the relative frequency approach? It means that it estimates the chance of something happening or the probability of an event. It is frequency of the event divided by the total number of frequencies. So here's an example, guys. Diversey paint example. Historical demand for white latex paint at 0, 1, 2, 3 or 4 gallons per day. Observed frequencies over the past 200 days. So here's a table, guys. So ito yung probability. Individual probabilities are all between 0 and 1. 0 greater than or equal to the event, less than or equal to 1. Then the total of all event probabilities equals 1. So yun, yung 0.20, 0.40, 0.25, 0.10, and 0.05, that is equals to 1. Objective approach can also be set using what is called the classical or logical method. Without performing a series of trials, we can often logically determine what the probabilities of various events should be. For example, the probability of tossing a fair coin once and getting a head is head equals to one half. Yung 1 is number of ways getting ahead, then yung nasa baba, number of possible outcomes, head or tail. Then yung isa, yung drawing a spade, it is 13 out of 52. That is 1/4. That is 25%. There are several methods for making subjective probability assessments. Opinion polls can be used to help in determining subjective probabilities for possible election returns and potential political candidates. In some cases, experience and judgment must be used in making subjective assessments of probability values. For example, a production manager might believe that the probability of manufacturing a new product without a single defect is 0.85. In the Delphi method, it is a panel of experts assembled to make their predictions of the future. Adding mutually exclusive events. Often, we are interested in whether on one event or a second event will occur. This is often called the union of two events. When these two events are mutually exclusive, the law of addition is simply as follows. Event A or B is equals to event A plus event B. For example, a single 6-sided die is rolled. What is the probability of rolling a 2 or a 5? So here are the probabilities. Rolling a 2 is equals to 1 out of 6. Rolling a 5 is 1 out of 6. Rolling a 2 or 5 is equals to rolling 2 plus rolling a 5. It is 1 out of 6 plus 1 out of 6 equals to 2/6 or 1/3. So, for example, in a math class of 30 students, 17 are boys and 13 are girls. On a unit test, 4 boys and 5 girls made an A grade. If a student is chosen at random from the class, what is the probability of choosing a girl or an A student? So here are the probabilities. Choosing a girl or a A is equals to choosing a girl plus choosing an A student minus choosing a girl and an A student. That is equals to 13 out of 30 plus 9 over 30 minus 5 over 30. That is equals to 17 out of 30. Events may be either independent or dependent. When they are independent, the occurrence of one event has no effect on the probability of occurrence of the second event. So this is the equation for the independent event. Events A and B equals to event A times event B. For example, for a fair coin toss twice, A, event that the head is the result of the first toss. B, event that the head is the result of the second toss. Event A is equals to 0.5 and event B is equals to 0.5. Multiply the two events and then you'll get the result of 0.25. When events are statistically dependent, the occurrence of one event affects or influences the probability of occurrence of some other event. It is also an event that relies on another event to happen first. For example, robbing a bank and going to jail, not paying your electricity bill on time and having your electricity cut off. So here's another example of dependent event. There are 6 black socks and 4 white socks in a drawer. If one sock is taken out without looking and then a second one is taken out, what is the probability that they both will be black? So, first sock is black equals 6 out of 10, that is 3 of 5. Second sack is black, 5 of 9. 2 black sacks, 3 over 5 times 5 over 9, that is equals to 15 over 45, that is 1/3. The probability of picking 2 black sacks is 1/3.
Hi, I am Zyrene Jade Broncano, and I am going to report about the revising probabilities with Bayes' theorem and then the general form of Bayes' theorem. Bayes' theorem is used to incorporate additional information and help create posterior probabilities from original or prior probabilities. Shown here below is the graph about Bayes' theorem. So, the Bayes' theorem is used to create posterior probabilities using the additional information or the new information and the original or prior probabilities. This means that we can take new or recent data and then revise and improve upon our old probability estimate for an event. So now I am going to talk about the revising probability with Bayes' theorem. I have here an example. A cup contains two dice identical in appearance, but one is paired, or the other or unbiased, and the other is loaded or biased. The probability of rolling a number 3 on the fair die is 1/6. The probability of tossing the same number on the loaded die is 0.60. We select one by chance, toss it, and get a number 3. What is the probability that the die rolled was fair? And what is the probability that the loaded die was rolled? So to answer the probability of rolling number 3 on the fair die is 1/6 or 0.16. We have here the probability of being fair is equals to 0.50, and that would have the probability of being 3 given that it is fair is equals to 0.166 or 1/6. Kay, diba, ang sa isa ka dice na atay, 6 numbers, 1, 2, 3, 4, 5, and 6. If i-divide nato na ang chances, maging 1/6 gid siya kay fair man. And if the probability being loaded is equals to 0.50, and the probability of being 3 given that it is loaded is equals to 0.60. Kay loaded man, so dako jud chance na mag number 3 ang ang mag toss or maging ang maday nga to. Tapos the probability of the probability given being 3 and it is fair, and the probability being 3 and it is loaded are the probability of 3 being 3 and fair is probability of 3 given that it is fair multiplied by the probability being fair is equals to kay ang 'di ba ang sa taas ganina ang ang probability being 3 given that it is fair is 0.166. So ibutang na to 0.166. And then the probability being fair is 'di ba naa po dito ganina tong 0.50. And i-multiply na to mag-result siya or magkaroon siyang product na 0.083. And then the probability given that it is 3 and loaded has the equation of the probability given that it is 3 being 3 and given that it is loaded is also multiplied by the probability being loaded. And same sa giingon ako sa fair side, naaman dito sa first na solve nato katong sa ang fair die is 1/6 daw, and ang probabilities ng loaded die is 0.60. So, 0.60 multiplied by the probability being loaded na 0.50, mag-result siya sa 0.300 or 0.30 or 30%. So, in the situation that we select 1 by chance, toss it and get a 3, we have here an explanation. If a number 3 can occur in combination with the state fair die or in a combination with the state loaded die, the sum of their probability gives the unconditional or marginal probability of a number 3 on the tossed. So here is the solution. The probability being 3 is equals to the 0.083 na to. Mo to answer na to ganina sa sa probability sang the probability of being 3 and fair and the probability of being 3 and loaded. So ang 0.083 mag-refer lang talaga sa tong first na explanation and also the 0.300, and this will result to 0.383. So if a 3 does occur, the probability that the die rolled was the fair one is, if the probability being fair given that it is number 3 is equals to the probability being fair and 3 divided by the probability being 3, and it is equals to 0.083 divided by 0.383, and this will result to 0.22 or 22%, na ang 3 kay mag-occur kapag ang na-dice na die is the fair one, and then the probability that the die was loaded is, here it is. So the probability being loaded given that it is number 3 is equals to P being loaded, and the probability of being loaded and it is 3 is equals to the probability of it being 3, and this is equivalent to 0.300 divided by 0.383, and this will have a result of 0.78 or 78%, and this means that kapag taas of chances or probability, ang meaning is ang na-die na dice is the loaded one, katong biased. And then mao, and these are the revised or posterior probabilities for the next roll of the die. We use this to revise our prior probability estimates. So ang prior probability estimates gid is katong fair one. So ang revised na probabilities using the base theorem in this example is the loaded dice. Moto kay nag-result siya sang taas na probabilities, while the prior one is or has the lower probability in between the two. So let's continue with the general form of Bayes' theorem. We can compute revised probabilities more directly by using the probability being A given that it is B is equals to the probability of being B given that it is A, and multiplied by the probability of being A divided by the probability of being B given that it is A, and the probability given being A add to the probability of being B given that it is A na may stress. Ano sa tawag ana basta hindi ko kabalo sa paano na siya basahon basta to may something na stress, and the probability of being A na may stress pod, where mo ni itong may A na may stress na ginamin ako, where A na may stress is equals to the complement of the event A. For example, ang A is ang fair die, then ang A is the loaded die, kaya ang complement man daw, so meaning the opposite one. Ganun. Now let's continue to the general form of Bayes' theorem. The conditional probability. The probability of being A given that it is B and is equals to the probability being AB divided by the probability of being B. From the previous example, we are going to replace A with fair die and the B with the tree road and the A na may stress with loaded die. So, ang equation nato ganina is the probability of being A and given that it is B is equals to the probability of being B given that it is A and the probability being A divided by the probability of being B given that it is A and the probability of being A. I-add nato sa probability of being B given that it has or it is A na may stress the complement of event A, and the probability of being a complement of the event A. So, mao ni ang ang numbers na-apply na to ang mga numbers. So, 0.166 i-multiplied by 0.50. And then, the 0 and then we divide it by 0.166 also times or multiplied by 0.50 plus 0.60 multiplied by 0.50. We will have the subtotal of 0.083 divided by 0.383, and it is equals to 0.22. So let's move forward to the further probability revisions. After the first roll of the die, the probability of the die is fair. So, ang fair may probability na 0.22, and the loaded or the biased one has the probability of 0.78. And after the second roll of the die, the probability of the die is fair if it has a probability of 0.067 and the probability of die being loaded or biased is 0.93. We can see na kapag na-revise ang atong probabilities, it has more greater effect or more greater probability than the prior, and that is the Bayes' theorem. So moving forward to my next discussion, which is the random variable. In probability and statistics, a random variable is described informally as a variable whose values depend on outcomes of a random phenomenon. A random variable is a variable whose value is subject to variations due to chance, either randomness in a mathematical sense. As opposed to other mathematical variables, a random variable conceptually does not have a single fixed value even if unknown. Rather, it can take on a set possible different values, each with an associated probabilities. A random variable's possible values might represent the possible outcomes of a yet-to-be-performed experiment or the possible outcomes of a past experience whose already existing value is uncertain. For example, as a result of an incomplete information or imprecise measurements. They may also conceptually represent either the results of an objectively random process such as rolling a dice or the subjective randomness that results from incomplete knowledge of a quantity. You can see in here is the examples of random variables, one of which is tossing a coin 3 times and let x be the number of heads. So remember, we are looking for the random variable, and therefore x will be the random variable because it could have a possible outcome of either 0, 1, 2, or 3. And the other example is let y be a number chosen using our RUNF function. Y is the random variable whose possible values are the numbers between 0 and 1. And there are two types of random variable: the discrete random variable and the continuous random variable. For now, let us talk about the discrete random variable. Discrete random variables can take on either a finite or at most a countably infinite set or discrete values. For example, the integers. Their probability distribution is given by a probability mass function which directly maps each value of the random variable to a probability. And below is one of the example of discrete random variable. So discrete random variable includes the values obtained from rolling a die and the grades received on a test out of 100. And the example we have shown here is the parang may arrow na ay mga red na lines pataas and may dots. This shows the probability mass function of a discrete probability distribution. The probabilities of the singletons 1, 3, and 7 are respectively 0.2, 0.5, and 0.3. A set not containing any of these points has probability of 0. So we can call that a discrete random variables. And the next one, the other type of random variable is the continuous random variable. Continuous random variable, on the other hand, take on values that vary continuously within one or more real intervals and have a cumulative distribution function or CDF that is absolutely continuous. The random variable has an uncountable infinite numbers of positive values, all of which have probability of 0, though ranges of such values can have non-zero probability. And below is also an example of or a representation of continuous random variable. And that example, the image shows that the probability density function or the PDF of the normal distribution, also called Gaussian or bell curve, the most important continuous random distribution. So ang karon na graph is mao nang ang ginatawag na Gaussian or bell curve. Ang pinaka-importante na continuous random distribution as notated on the figure. The probabilities of intervals of values corresponds to the area under the curve. Selecting numbers Random numbers between 0 and 1 are examples of continuous random variables because there are infinite numbers of possibilities. So the probability distribution in probability theory and statistics, a probability distribution is the mathematical function that gives the probabilities of occurrence of different possible outcomes for the experiment. Probability distribution yields the possible outcome for any random event. So, the first one is the probability distribution of a discrete random variable. The probability distribution for discrete random variables can be displayed as a formula in a table or in a graph. The formula, table, and probability histogram satisfy the following necessary conditions of discrete probability distribution. 0 is less than or equal to the fx and less than or equal to 10, less than or equal to fx, and less than or equal to 1, or either the value of fx are probabilities, hence between 0 and 1, and or the summation of fx is equals to 1, the summation of fx is equals to 1. Either adding the probabilities of all these joint cases, we obtain the probability of the sample space, which is 1. Sometimes the discrete probability distribution is referred to as the probability mass function or the PMF. The probability mass function has the same purpose as the probability histogram and displays specific probabilities for each discrete random variables. The only difference is how it looks graphically. The next one is the expected value of a discrete probability. The expected value of a random variable is the weighted average of all possible values that this random variable can take on. Expected value of a discrete random variable, the sum of the probability of each possible outcome of the experiment multiplied by the value itself. Suppose random variable x can take a value x1 with probability of p1, value x2 with probability of p2, and so on, up to the value of xi or d with probability of the pi or the last value of x and the last probability of p. Then the expectation value of random variable x is defined as expected value of x is equals to the value of x1 and the probability of p1 plus the value of x2 and the probability of p2, and so on and so forth, which can also be written as the expected value of x is equals to the summation of xi and pi, which means that the ng xi or pi mo raga ng x is x to the nth power, something like that. Good. And the last one is the variance of discrete probability distribution. The variance of probability distribution is the theoretical limit of the variance of a sample of the distribution as the sample size approaches infinity. And here's the formula for the variance of discrete probability distribution with the n possible values. So, ang variance is from the get-go, let me say that the intuition here is very similar to the one for means. The variable of a probability distribution is the theoretical limit of the variance of a sample of the distribution as the sample size approaches infinity.
Good morning everyone, my name is Camila Serra and I'm going to report the remaining topics. So, first is the binomial distribution. Many business experiments can be characterized by the Bernoulli process. What is this Bernoulli process? The probability of obtaining specific outcomes. So, this process is described by the binomial probability distribution, which is our topic. And in order to be a Bernoulli process, an experiment must have the following characteristics. We have 4 criteria. First is each trial in a Bernoulli process has only 2 possible outcomes. Maybe head or tails, pass or fail, or success or failure. So, defective or good, and so on and so forth. So, number 2, the probability stays the same from one trial to the next one. And then, number 3, the trials are statistically independent. And number 4, the number of trials is a positive integer. So, a common example of this one is the tossing of coin, which is the heads or the tails. So, in the table given, which is the table 2.7, the given was binomial probability distribution for n is equals to 5 or 5 tries, and then p is equals to 0.50. So, as you can see on the table, number of heads from 0 to 5 respectively, and then probability is equals to, yung ano nyan is substitute na agad yung sa formula, which is the probability of r successes in n trials is equals to n factorial divided by r factorial, open and close parenthesis, n minus r, and then p raised to r times q raised to n minus r. So we're done with the solving problems with the using the binomial formula. So let's proceed now to the solving problems with binomial tables. So the problem given here is MSA Electronics is experimenting with the manufacture of a new type of transistor that is very difficult to mass produce at an acceptable quality level. So every hour, a supervisor takes a random sample of 5 transistors on the assembly line. So the probability that any one transistor is defective is considered to be 0.15. So MSA wants to know the probability of finding 3, 4, or 5 defectives if the true percentage defective is 15%. As you can see on the sample table for the binomial distribution, you could see the P 0.15 or the 15% on the third column, and then let's look on the 5, which n is equals to 5, and then kasi ang hinahanap dito is yung 3, 4, and 5 na value. So, itatapat mo lang kung saan siya nag-meet yung sa x and y axis niya po. Let's proceed. The normal distribution. The normal distribution affects a large number of processes in our lives. For example, filling boxes of cereal with 32 ounces of cornflakes. Each normal distribution depends on the mean and the standard deviation. It is one of the most popular and useful continuous probability distribution. For the illustration, figure 2.8, normal distribution with different values for mean. So as you can see, the first one is same lang ang mean and then the standard deviation, so equal lang siya. And then dito is smaller yung mean but same yung standard deviation, and then yung sa last part is yung sa pinakababa na part is larger yung mean and then same standard deviation. Area under the normal curve. Because the normal distribution is symmetrical and its midpoint is at the mean, values on the x-axis are then measured in terms of how many standard deviations they lie from the mean. So, as you may recall from yung earlier discussion which is na-discuss ni Z, which yung probability distribution, the area under the curve in a continuous distribution describes the probability that a random variable has a value in a specified interval. So, when you are dealing with the uniform distribution, it is easy to compute the area between any points from A to B. So, the normal distribution requires mathematical calculations beyond the scope of this lesson. So, but the tables that using the standard normal table, so when finding probabilities for normal distribution, it is best to draw the normal curve and shade the area correspondingly to the probability being sought. So, this standard normal table, yung paggamit niya is we have two steps. First is to convert the normal distribution to what we call a standard normal distribution, and second step is look up the probability from a table of normal curve areas. Well, the probability tables for the normal distribution can provide precise probabilities. Many situations require less precision. So, the empirical rule was derived from the normal distribution and is an easy way to remember some basic information about the normal distribution. So, the empirical rule states that for a normal distribution, approximately 68% of the values will be within one standard deviation of the mean. Approximately 95% of the values will be within 2 standard deviation of the mean, and then almost all about 99.7% of the values will be within 3 standard deviation of the mean. Distribution. The F distribution is a continuous probability distribution that is helpful in testing hypotheses about variance. So, the F statistic is the ratio of two sample variances from independent normal distribution. So, every F distribution has two sets of degrees of freedom associated with it. One of the degrees of freedom is associated with its numerator, the numerator of the ratio, and the other is associated with the denominator of the ratio. So, the degrees of freedom are based on the sample sizes used in calculating the numerator and the denominator. So now let us proceed to the exponential distribution, or also called the negative exponential distribution. So it is used in dealing with queuing problems. So you're asking about something situational or ano. So the exponential distribution often describes the time required to service a customer. So the exponential distribution is a continuous distribution. And one good example here na nakalagay is yung Arnold's muffler example. So, let's see how it was solved. So, the probability that the mechanic will install a muffler in half an hour is equals to 0.7769. You'll just substitute the values given sa formula na andun sa problem. So now we're down to our last topic, which is the Poisson distribution. The Poisson probability distribution is used in many queuing models, just like as yung previous na distribution method, which is the exponential distribution. And to represent arrival patterns. So, an important discrete probability distribution is the Poisson distribution. So, take note of that. Okay, to sum it up, this lesson or this chapter presents the fundamental concepts of probability and probability distribution. So, probability values can be obtained objectively or subjectively. A single probability value must be between 0 and 1. And the sum of all probability values for all possible outcomes must be equal to 1. In addition, probability values and events can have a number of properties. These properties include mutually exclusive, collectively exhaustive, statistically independent, and statistically dependent events. So, rules for computing probability values depend on these fundamental properties. It is also possible to revise probability values when new information becomes available. This can be done using Bayes' theorem. We also covered the topics of random variables, discrete probability distributions such as Poisson and binomial, and continuous probability distributions such as normal, F, and exponential. A probability distribution is any statement of a probability function having a set of collectively exhaustive and mutually exclusive events. So, all probability distributions follow the basic probability rules mentioned previously. So, that's all. Thank you for listening po.